In this video, we'll do a brief overview of the OSI model and how it can be used to help you better understand networking. And throughout this course, you're going to hear me refer to layer 2 or layer 3 or layer 1. Those are all layers of the OSI model. And the purpose of the OSI model is basically to help make networking easier to understand. Now, some of these layers are going to be more important to us than others. So layers 7, 6, and 5, we're not going to spend a lot of time talking about those in this course. That's the application, presentation, and session layer. And a lot of that is just stuff that's happening in your computer. So if you're using an email application, for example, that's stuff that the email application itself is doing. And so we're not going to delve too deeply into those, but layers 4, 3, 2, and 1 are much more important from a networking perspective. And so we'll start from the top down: application, presentation, session, transport, network, data link, and physical. And an easy way to remember these layers is the little mnemonic device shown here on the left. All people seem to need data processing. So the first letter of each of those words is the same as the first letter of each of the layers of the OSI model. And so if we can remember all people seem to need data processing, it'll help us to remember the 7 layers of the OSI model. So we could go on and on for an extended period about the OSI model, but frankly, I think you would find that relatively boring. So let's walk through one example of the OSI model in action. And as we start talking about things like routers and switches and Ethernet and IP addresses throughout the rest of this course, you'll hear me talk more and more about the layers of the OSI model, and it'll make more sense as we continue to move forward. But in this example, let's assume that I'm on my computer and I want to upload a video to YouTube. Well, that's going to involve all of the 7 layers of the OSI model. And so I'm going to create this video, and then I'm going to launch my web browser and go to YouTube. That web browser is handling layers 7, 6, and 5, the application, presentation, and session layers. The layer where we really start to get concerned with as networking people is layer 4. Layer 4 is going to be the transport layer. And so in this case, we're using a web browser. A web browser communicates using HTTP. That's the layer 4 protocol. And basically, layer 4 is going to control things like how do the two systems communicate. So basically, my computer needs to communicate with the servers at YouTube. It needs to agree upon, hey, are we going to check the data that's being sent for errors? What's going to happen if some incomplete information is sent? They're going to negotiate the parameters of this transport using layer 4. But the areas that we really focus on the most of all as a networking person are layer 3 and layer 2. So let's go to layer 3, the network layer. And so now I've got this video that's ready to go. It's sitting in my browser and I'm about to click the upload button. Well, that upload has to go to some destination IP address. What is the address of the system that it is going to be sent to? That's layer 3, the IP addressing information. And so now we know, hey, this needs to go to a layer 3 device that's available somewhere on the internet. Maybe my computer doesn't know how to get there, but what it's going to have is something called a default gateway. It's going to have a router that it uses to send traffic to when it doesn't really know where to send it. So my computer at layer 3 is going to say, oh, we're trying to upload this video. Let's send it to our router. Our router will know how to get there. Let's send it to the default gateway. So now that it's determined what the next hop is, what the next step along this path is going to be, it has to actually get the data to that router. And that router is connected on a local area network. So in this case, it's going to be an Ethernet network, but there are other examples of layer 2 networks. And the biggest difference between layer 3 and layer 2 network identifiers is that the layer 2 network is a local network, and the addresses on this layer 2 network really only make sense within this layer 2 network. So the layer 2 network is going to encompass things like the MAC address of my network interface card, the physical switch. The network interface card on the router is going to have a MAC address. It's going to have these addresses that the devices use to communicate with each other over layer 2. And so my computer is essentially thinking, well, I need to send this traffic to my router. The way that I get to the router is through my network interface card. And so in order to send something out my network interface card, I need a source address. That's going to be the MAC address. That's going to be layer 2. And the switch is going to have something called a MAC table. We'll learn much more about this later on. But basically, the switch is going to know, hey, the router has a MAC address too. It's going to know how to get to that router. And so at each layer, addressing information is being added. So at layer 4, the addressing information that's being added is the TCP and UDP port numbers. At layer 3, the source and destination IP addresses are being added, and they're being added as headers. And at layer 2, the source and destination MAC address are being added as headers as well. And then layer 1 is the physical layer. So layer 1 is the actual physical hardware. It's the network interface card connected to a cable. And that traffic is going to flow to the switch. The switch is a layer 2 device. It is going to analyze the source and the destination MAC address. The destination MAC address is my layer 3 device, my router, which is going to analyze the source IP and the destination IP. The destination IP is going to be these servers at YouTube, and away it goes. So let's talk just a little bit more about these headers. So we start out with layers 5, 6, and 7 again, and this is basically the payload. The payload is what am I trying to transmit? Now, in our little example here, the payload is going to be this video that I want to upload to YouTube. And so we start with that. The data that we actually want to upload, that's the payload. We're going to call that layers 5, 6, and 7. Once we've gotten that far, then we have to append the port numbers. So this might be TCP traffic. We might be doing FTP or HTTP. It might be UDP traffic like DNS or NTP. But regardless, we have to put a port number on. And so essentially what it's going to look like is kind of like this. We're going to have our payload. That's the data that we actually want to send. We're going to append a little header in front of it with the port number. We're going to append another little header in front of that with the source and destination IP. That's happening at layer 3. And by the way, TCP/IP, you may have heard of that acronym. That's just the combination of layer 4 and layer 3, TCP/IP. And then before it can actually go out on the physical network, we have to append one more header. This is the layer 2 header. In this case, with an Ethernet network, we're talking about the source and destination MAC address. But there's all sorts of layer 2 networks that we're not really going to talk about here, like Wi-Fi or fiber channel. Once all of those headers are appended, then it can actually be transmitted onto the physical network itself. Now, I understand that this is kind of ambiguous, and it might be hard to visualize exactly what all of these concepts mean at this point. But as we talk more about switches and routers and the real-world applications of the OSI model, these concepts should make more sense.